So frq details blocks 1 and 2 of masses m1 and m2 respectively, and they're connected by a light string as shown above. These blocks are further connected to a block of mass m by another light string that passes over a pulley of negligible mass and friction. So these two blocks move with a constant velocity v down the inclined plane, which makes an angle theta with the horizontal. The kinetic frictional force on block 1 is F, and that on block 2 is 2F. So for part A, on the figure below, draw and label all the forces on block M1. So there's 4 forces acting here: the gravitational force acting down, the normal force perpendicular to the incline, the frictional force opposing the motion, and the tension moving the block up the incline. So we have to show this in the provided diagram. So if we want to see that, we'll see it as we see it like this. So normal force perpendicular, so this is normal force. So it moves down, so force friction goes here, and then tension force also goes here, and then finally gravity is like this. So that's part A. Second, with part B, we want to calculate the coefficient of kinetic friction in between the inclined plane and block 1. So to do this, we use the thing that says that friction force, mu equals force friction divided by force normal. So we substitute friction to equal F, and then force normal is m1g cosine theta, and then this ends up with F over m1g cosine theta. And then by plugging in the values, we see that is what mu is as the answer. So for part C, we want to determine the value of the suspended mass m that allows blocks 1 and 2 to move with constant velocity down the plane. So we do this by analyzing the suspended mass m that balances the system when the velocity is constant. So we start with the net force and equation and rearrange for m, and we'll get equals sine theta and then over g. And then we can then substitute F equals mu times L1g cosine theta to finally gain the final answer here. And that will be the answer. And then for D, the strings between blocks 1 and 2 are now cut, and then we determine the acceleration of block 1. To do this, we equals force equals ma, and then the forces are the friction forces are F equals mg sine theta minus F, and substituting mu times m1g cosine theta for F, we end up with and then we simplify for A, and then we get A equals g sine theta minus mu g cosine theta, which is how you find acceleration here, and that is the final answer. And once you get all these things, then you can conclude. I can conclude here by emphasizing it's really important to analyze these different forces and kinematics angles when solving, and you really have to consider and factor them when you're solving for these things, and it's really, really important.